The spread talks about the distribution of the data, and of course, though there are many measures of spread that are available in the statistics space, the most common thing industry uses is the standard deviation, which is nothing but as a simple measure we are talking of the spread in the data. Is because see, average always talks about something in the middle, but how are the other elements? Are they very close to the center or are they very much away from the center? So that is what is being understood by the measure of spread, right? So talks about either the dispersion or variability or the scatter in the data, and sometimes we do try finding out the deviation from the mean. Most commonly, standard deviation as a definition is nothing but average deviation from the mean. Whereas sometimes I may be interested in finding out the deviation with respect to any other value also. Sometimes I may do it with respect to median. Sometimes I may do it with respect to 0. So at the end, the common definition is any deviation from a particular point. So there are so many terms which are generally used. Of course, the standard deviation is the very common one. It is used just like the way mean is used as a measure of central tendency, right? Mean, one thing to remember, there are two different symbols for the mean, mu and x bar. X bar is always associated with the sample mean. It's a very common term to use. You should not use these two things interchangeably, right? When you are using x bar, it means the mean of a sample of data. But when we are using mu, it is the mean of the population. So to a large extent, we always work with the samples only. But when we are estimating, we estimate the population parameter. So we should use the mu and x bar accordingly. The same thing holds true with the standard deviation also. When I talk about population standard deviation, I use sigma. Whereas when we talk about sample standard deviation, S is being used. So the difference of these two should be, because sometimes you see in the books also saying S is a good estimator of sigma, or S squared is a good estimator of sigma squared. So because whenever you are estimating something, you estimate the population value. But the data is always specific to a sample. So the whole world of statistics runs like you use the samples data to estimate the population stuff. Right? So the differentiation between these terms need to be comfortable with. And population is the complete data. Let's say you are having the whole list of policies. Probably there is nothing beyond that. That is what we call as the population. But whenever we work, we don't access the whole data in the world. Right? When I have to make some conclusion, let's say elections. Right? If I go to each and every voter and find out to whom they have voted, then it is the population. But I go only to some set of people and take their data. Even when you are talking of insurance policies or probably estimating the mortality of a particular person, whatever it is, the probability of accidents, whatever it is, I will not take all the accidents in the country and I cannot get the whole data. Right? Probably some accidents don't get reported. Lot of things may happen. So I may not get the whole data. So whatever I work on is only some portion of the whole data. That is what we call as the sample. So any calculations we do, generally, we work on the sample. Even in the exam, if he gives a data, he hardly gives some 50, 60, 100 elements. Right? Using that 100, he asks you to generalize. So that is where we are actually using statistics itself. I am using a sample to do something about the population. Right? So that's where even in terms of terms also, S is something I use for sample standard deviation, and sigma is something which I use for population standard deviation. So we'll look at the measures of these two, and along with that there are a couple of other dispersion measures also. One is called as the moments, right? We'll look at the formulas and all associated with each of them. The moments is a very general term. Even the mean and the variance are also special cases of moments. We'll see that. Then there is a mechanism called range. Range is easiest to find out, which is nothing but highest value minus lowest value. So that's the reason it is not used more extensively, because the form, it's very simple and only two values are considered. Even though my sample will have 50 values, range only considers two values, highest value and lowest value. And if the highest is an outlier and the lowest is an outlier, right, the difference looks very, very high. So it says the data is completely dispersed, completely scattered. Probably if I remove that one outlier, probably the data looks more concentrated in a specific area. So that's where range is not generally used heavily. And of course, we'll look at the interquartile. So these four are the ones which are typically considered as the measures of dispersion as far as our syllabus is concerned. Now, how do I look at each one of them? When we say standard deviation, we cannot compute the standard deviation